Regine is the head of flight testing at the company whose name you see on the screen here, RS Flight Systems. She has a background in aeronautical engineering, having studied at the Technical University of Munich. What is of interest to me is that she prefers to go flying in aeroplanes without engines, which I always find rather scary. She's a qualified sailplane pilot. But she's going to talk to us today about ways in which digitalization in flight testing could be a cost-saving factor.
This conference will now be recorded.
And I give you the floor.
Thank you for that. And yes, I'm very happy to start with a presentation about the topic of digitalization in flight testing as a possible cost-saving factor. So basically, we're talking about efficiency here, which was mentioned before. Just to give you a little background, I would like to show the types of flight testing as we do them in our company. So just to give you a better picture of where I'm coming from. So we also do certification flight testing, maybe sometimes also on a smaller range, so not really in the military field. And we also didn't do anything for airliners, obviously. So maybe smaller aircraft types. Yeah, then a specific part of that, we also do noise measurements. I mentioned it separately because it's just always, or very often in our company, a separate project. And then we have a specific case simulator validation data gathering, which means that we gather data for simulator development. And in the context of flight testing, you can imagine it like a shorter version of a certification flight test in terms of the program, but you don't have a fixed order. So basically, you can go through the program much quicker than for a certification flight test. Right, this for the background. Then how did I come up with that topic? So first of all, I'd like to share my impression when I saw the announcement of the symposium theme. I was very surprised, and I was like, okay, I can 100% identify with that, like chronically low on product budget and stuff like that. But I don't want to bore you with my small company problems, so I try to pick something that is hopefully for interest for everybody. And yeah, to start with, like, just show you like how I came up with the topic of the presentation. So first of all, in any flight test-based data gathering, you have to legitimate the purpose of a test with the safety of a flight. And there just needs to be a balance that is acceptable, which we all know. But if you then add cost efficiency into this triangle, actually, even though I put now just one arrow here, there's very quickly a potential conflict visible. Which is why I thought, okay, let's have a look at what do we have as topics that are just not safety related, or maybe barely safety related. And what I came up with for this presentation, even though there's obviously much more, is data handling, data post-processing, and data analysis. So we're going to talk about the data package. Yeah, this is now a little index that will guide you through the presentation. At first, I would like to define the data set as I'm using it here as an example. So it's obviously a simplified version, and you need to consider that. And then I go on with some methods that are part of the digitalization process, and I just point out the most important ones, which is the format, so the digital format of parts of the data set, the identification of links between parts of the data set, and then obviously the potential for automatization if you have certain prerequisites. Along with that goes hopefully a resulting cost reduction, and in the end I have a little discussion. So let's start with the data set. I picked 4 parts of it now. So obviously we have the flight test instrumentation recordings, which are like the central unit of everything. I put down separately intercom and video recordings just because they have a different format. Then we have mass and CG and flight test cards as examples for additional information that are part of the data set. FTI recordings in mass and CG are naturally digital, or at least the mass and balance can be done very easily in a digital way, so there's no problem with the format. here. For video and intercom recordings, yes, obviously the format is first of all digital. The problem is that the content within it is not necessarily like readable as it would be in a flight test card, for example. So if you want to learn about a comment that was said in flight throughout the test, you would have to listen to the intercom recording, and it's not something that you can just look up in a flight test card or that you can look up in a database that is created for the entire data set. Right, and then at the end we have the flight test cards, which I picked now in this example to be sort of the black sheep in this version, and we'll go more into detail about them on the next slide. So obviously in the background you can see a manually compiled flight test card. And yeah, I tried to pick like one of the worst examples that I could find. Obviously, I'm aware that there are a lot better versions of that, not loaded and everything, but I'm trying to make a point here, so this is why I picked that one, yeah. And yeah, what you can see here is issues like there were not enough lines for test repetition, so people were writing at the bottom of the flight test cards additional test points, which are then not in the normal format, and it just gets a little bit chaotic. Also, you can see that there were numbers written, they were wrong, so they were corrected, and it's difficult to read them. And then you see also things like, for example, this -6 degree at the very top. I don't even know what it means. So, and where is it related to? Is it even important? Maybe it's not. It could be just anything. It could be a heading. It could be like, maybe it's just degrees Celsius. I don't know. So it's just very difficult to get that information organized and understood. Right. But obviously there's not only negative points about compiling flight test cards manually. The positive side is that crew members are all very well trained to write them in flight, so it's just a standard approach. It's a fail-safe method in flight, so the only thing that could happen is that you lose your pen, but as far as I know, all flight test engineers have so many pockets that I'm sure that there's a spare pen inside that can be used in that case. And also there are no or barely any safety concerns in this process. Right, but the negative parts are we have limited space for comments and test repetitions. We have issues in readability after the flight, and it's just that like this is a format which is not digitally usable at all. So that's a problem with it. If you wanted to change that, you would have to have obviously a device. So you need a PC or a tablet-based version. If you have an aircraft with a cabin, then you can work on a PC, which is, let's say, more comfortable and easier to do. If you're sitting in the front as a test engineer on a co-pilot seat, you would have to use a tablet version, and that needs some more thinking, let's say. So you might need to adapt the format into a way that, yeah, it doesn't include a lot of typing, let's say, because obviously you don't have the keyboard. And maybe what helps is that you include drop-down menus where you already include like predefined answers. And then you can also like just let the crew members really test their way of compiling it and deciding on it. So some prefer to use like, for example, the swiping version of a tablet, or instead you could use one of those pens to write something, or just use your fingers. So there are multiple versions, and it depends also a little bit on how people use their phones and, privately, and yeah, what is the best way that works for them. In any case, it's something that needs to be trained, and I'm aware that many flight test organizations already use digital flight test cards. It's basically used as an example now to show how big the step can be, even though it seems quite small actually. Right, going to the next slide, we would like to have a look at a different thing in this whole format discussion, let's say. So the transformation of data formats. What you see here is a screenshot of a airspeed calibration with an analog instrument. which is the challenge in it basically, because obviously if it's analog, you don't get any data out of it. And what we did then to help with here, help on the analysis side, is that we brought the independent source data into the video format. So it just makes it easier to read for analysis. Obviously, this is not, let's say, the ideal version of it, and there's better that might be an idea to do in future. So if you actually try to set up a reading of video data and transfer the data into actual digital, into a normal data format, let's say, that can be used digitally. Challenge with that is that the video quality is often not that good, and it's negatively influenced by sunlight, as you can see in this example. You also have like mirroring effects and stuff like that. So yeah, it's just a challenge to train machine learning software for, let's say, for correct identification of parameters. And what is happening then, you can spot those. So actually, you're lucky if you spot those errors right away in the resulting data sets. So for example, if you have zeros, or maybe also the other end, if like the upper values, whatever the limit is in your software. And then below you can see a jump like from 550 to 350 in the airspeed, which is obviously impossible. So one of the two has to be wrong. And you need to identify that either manually or like with another correcting software. So let's say, at least for us, this is not part of our standard process, but who knows what the future will bring. So it's maybe a nice opportunity to improve that. To summarize this, I'd like to say again, the native data format should be always digitally usable whenever possible. So this is like really the core of everything, and needs the most thinking of it, I guess. Yeah. If you can fulfill that, maybe take decisions based on the end user's perspective, not so much on the test team perspective, because at least, yeah, or well, it depends. If you're obviously in the test team already, the persons who are analyzing the data, then you're the same. But just try to put yourself into the user's perspective to improve or just help a little bit, even so it's maybe not perfect. Also, never forget the safety aspects. Difference in every flight procedure, technique, instrumentation, or any other might cause a different hazard than the version before. So those need to be identified and thought through, obviously. And also every change in a method just needs training. So I'm sure you obviously all know that, maybe even better than me. But I wanted to mention it because it's just really important. Right, then links between part of the data set. So this is sort of the second step that I want to present. And what I'm doing here is to simplify the example, is that I relate only directly to the flight test recordings. So every source that I presented before has a to and backlink to a different source, but not in between each other, just to the FTI recording. And one of them, and the most important, is the flight test card. So you need a flight number and an event marker to identify a maneuver in your data set. And the test name is obviously written in the flight test card and not in the FTI recording. Then we have the mass and balance. This is more like already an example which can be seen as a post-processing step if you want so. We have like, we need the fuel from the FTI recording and calculate based on that specific weight and CG for one test point, and then feed it back into the data set, or at least the database. Right, and then we have the video and intercom recordings I mentioned before. So again, it could be done based on flight number and event marker if the recorder can be integrated in a flight test instrumentation. It's differently if you wanted to use, for example, action cams outside of the aircraft or installation or whatever. So just a system that cannot be directly connected and that you can only use maybe UTC time, but also there you cannot be really sure that this is the same as you get from a different GPS antenna. So you need to be careful with that and maybe also think of different solutions to synchronize. Okay, then what we can do with that is create a database for the flight data set of a campaign, or also just for a single flight, obviously. And what we do is that we define or we give every test, every maneuver a test ID, which is formed out of the flight and the event number, as I mentioned it before, because this is like the most prominent link between all data sources. Yeah, it's called top marker in our company. I'm sorry for that. That's very German, but yeah, so don't get confused by that. In any case, now that you have the database, you could filter, for example, for a specific test, so a takeoff, let's say, and if you have the weight and balance in there as well, you can filter for the heaviest version, and then by the test ID, you would find your data set. The database can be directly used as an interface for data analysis tools, and obviously by creating the database, this shouldn't be done manually if possible. So don't copy paste manually items, but use just software-based versions that help you to get the content of the flight test cards, maybe even flight test instrumentation recordings. So for example, the fuel at a specific test point, and also the mass and balance calculation into it, but in an optimized way. And the same as well also for data post-processing, cuttings of maneuvers, but it all starts like with this link between flight test card and data set. So it's very important to start at the roots and have them done like in a way that is good for further use. I also want to give you a quick look on like an example for integrated software solutions to look at the data. We again have on the right the flight and event marker test ID, and you can click on it, and on the left you would see like this yellow marked area. It gets marked automatically just to indicate where your maneuver is. Then in parallel, you can also look at time synchronized videos. This is now actually from an action cam and zoomed in to read the IASI. And you can then see like what, for example, airspeed and pressure altitude are compared to your instrumentation independent source system at a specific test point. Right, then let's talk about the resulting cost-saving factors. Obviously, time of preparation for the data package, and I mean really the whole thing, so including all post-processing and everything. It obviously depends on where you're coming from, but I can say like for our company's experience, it was just a huge step. So we went from like 30 man hours or something down to 3 maybe to have everything done really. And it was mainly due to obviously the digital flight test cards, and then also just this whole post-processing chain, which wasn't even such a big invest. So it was more like this thinking it through and relating things, also including obviously methods to test if you're if what you've done is correctly and everything. But it just, at least for our case, it worked out really well. Secondary effect that the data analysis can be done really shortly after the flight. So you can hand over the data to the analysis team or like part of the test team, whoever it is, right after the flight or at least on the next day already in a format. And this is really important because I know that it's very easy to send out like just the flight test instrumentation data, but like the entire data set as an integrated one, that helps a lot with the analysis, obviously, if you have all additional information included. Yeah, and then you could even do things like, this is just an example now, plan for loops. So for example, if the test case allows it, you could like skip some variations in the planning and reduce it to an absolute minimum, fly those, give the data into analysis, get a feedback right away, and then only repeat something or add variations if that is really needed. So this is just a method to reduce flight hours, basically. Hopefully, depends on the test, obviously. And then the other part, more related to the analysis team, is like, I mean, we're obviously doing the flight testing to answer some questions, and sometimes the result is quite surprising, and that leads to, let's say, remaining question marks if it was really not influenced by any circumstances, if something is repeatable, whatever it is. So if the analysis team in a detailed analysis spots something like this, it's just very helpful for them to give this information back to the test team, but like not just a year after, so in a short time frame, yeah, help to improve the entire or the integrity of the data set, actually. Right, so discussion and outlook. Let's go back to the initial question, which was, can digitalization of flight test activities save budget? My answer is absolutely yes, or at least it worked for us 100%, even considering the investment we had. And then we also have to look again on the limitations. Obviously, it's the usability of the native data format, and we had the example of the videos here. But we also have like test activities with, for example, single pilot aircraft types. As you saw, maybe the Messerschmitt and some examples. It's just not possible for the, it's obviously not possible for the pilot to write a digital flight test card during such a flight test. So what we did is that we had like this small display here where you can press the button to set an event marker. And due to the intercom recording, a comment was taken into account for this, and could be documented afterwards, everything like more in a report format into a proper flight test card format. Yeah, then, well, as last step, I would just like to mention, because I had it before in an example already, there's obviously huge potential in developing technologies like machine learning. It's not a standard approach for us yet, but I think this is the perfect handover to the next presentation, which should be about this topic. And yes, this was it from my side. Thank you very much for listening. And I saw that there were already some questions. I just didn't read them quickly enough, so I guess
no,
I have to go.
Don't worry. You were busy with your excellent presentation, for which thank you very much. And yes, you're right. It's generated a great deal of questions and comments. I think it's a topic which many of us are interested in. I know certainly here in Toulouse, it's a subject which we keep talking about and are trying to find the good solution. We've got about 5 minutes for questions, so we'll try and run through some of them quickly, but perhaps you will be able to take the time during the rest of the session, if you're available, to chat privately with the people who are asking the questions and give them more detail. The first question from Andrew Barber was for the first slide, and we see it again on the second. He wants to know if you had a Merlin engine in the BF-109, but that's not really linked to your presentation, so. Right,
you mean the Messerschmitt, right?
Yes.
Yeah, well, we have so many different versions of the Messerschmitt. I don't know. This doesn't have the original engine. I know that.
There you go, Andrew.
But there were, yeah, there were different versions. So I don't want to say this too loud.
No, okay, no problem. A question which has come from several people, including Julius at Munich, at the Technical University of Munich, but also my colleague Ferran from Airbus in Hamburg. It's to know if you've found a good working tablet or iPad or device or a pen, or is there something you would recommend, or is it anything goes?
Yeah, so iPads, I guess. I know there's some other challenges coming with it, so they don't really tolerate heat so much, but I mean, as long as you be a little bit careful with it, it's still the device that works best for us. And then it really depends on the people using it. So I, for example, myself, I like using the swiping functionality for the keyboard because this is really quickly, but others just don't use it or don't like it so much. So they're using like this pen because it's probably easier to do them with fingers or whatever, for whatever reason. It's really a matter of personal training, I guess, and just try it out and try different methods, different tablets maybe also out, and also tablet size, obviously. So they're like the mini versions and the bigger ones. Both have advantages and disadvantages, but
yes, we would say in English, horses for courses. You have to find the best adapted solution.
Yeah.
And I think the difficulty is in finding a solution which is agnostic, which you can interface between any input device and any data recording device, and somehow defining a way in which any parts of the system could work together. I guess that's quite a challenge too.
Yeah. Okay.
There was a question.
Sorry, I can't give a clear answer.
No problem. There was a question from Rudolf talking about synchronization. It was a technical question saying, how do you ensure that all of these devices and databases and recording means are synchronized in time? Do you have anything you could say about that?
Well, so our normal video system is like simply time synchronized by method. So it's included into the bus system of the flight test instrumentation. No problem with that. Then the event marker obviously gives a very good indicator for everything that is like written in any kind of documentation. And well, maybe for like, I don't know if this is the target of the question, but if it's about like action cameras and things, so we try to have at least like an indicator at the beginning of the recording, for example. So it could be if sound recording is included, just clapping, or it could be like something that you can see in a picture. So obviously, if you're filming the cockpit, you can see the indication of the cockpit instruments, and by that you would see like parameters where you can at least approve the synchronization. Because I really have to say that GPS or like GPS-based UTC time is not good enough if it's not the same antenna. And this is the problem here, basically.
Yeah, a common issue for many of us, I think, that synchronization. And there's another question on synchronization, but from a completely different type, which has come in from Sebastian Rommel, who wants to know, and I guess this is linked to the type of flight testing which he and his team perform. If you have a pilot who is flying the aircraft and a flight test engineer who is not in the aircraft, he might be on the ground. Does your system allow any kind of communication between the on-ground and on-board versions to ensure that everybody's working from the same test card?
Yeah, so let's say we're working on it, especially for wind at the moment, which is one of the things that we would like to send to like this little display that I showed. Let's say we're in the development on it. It works sometimes, but it's still a prototype. But this is, for example, one of the parameters that are very useful to be sent to an aircraft, because it just gives like, a full picture of the wind situation outside.
Okay, and I think we've just got time for one more question, which has come from Lysandra. I hope I'm pronouncing that right, Lysandra. Who wants to know if you think that the use of these new ways of working, these new tools, could have an impact on the way the team members work together. Can you say something about that?
That's a very interesting question. So I haven't noticed any negative impact, but maybe I should think about this. Maybe, I don't know.
It could be a positive impact as well. I mean, if it is helping people to coordinate, then that's a good thing.
Yeah.
Well, as I say, perhaps you could find a few moments to chat directly with Lysandra and try and...
Yes, exactly. I think I need an indication for the trap that might be on the way to understand what the question is targeting to.
Okay. Well, Regine, thank you very much for taking the time to talk to us this afternoon, for starting off with a subject which is obviously of great interest to a lot of people. I think it's something which we will see more and more in the near future. It seems like it's the way in many walks of life and not just in flight testing. So I think you've got plenty of work ahead of you. So thank you once again.
Thank you.